Finally, I'd like to talk a little bit about applications of click models because, all right, now we started this set of videos with saying there are many interactions and we focused on clicks, and then we said clicks are very biased. Actually, all interactions are biased, and we just discussed clicks. Mouse movements are biased, scrolling is biased, everything is biased. Clicks are the most widely studied. We also tried to remove bias from time. For example, we tried to remove, well, I didn't do that myself, but one of our PhD students tried to remove bias from mouse movements. So we tried to remove that bias. We built those models. We believed we removed it. So what do we do with that? I already mentioned a few things on the way how we can use the results, but here I'd like to focus on that a little bit. So applications of click models. First to do, before we go into applications, I'd like to show what we actually can get after we estimate click models. So we create a click model manually by hand. We create those rules that I showed you for BBM, for cascade model. Then we run either a maximum likelihood estimation or expectation maximization. And finally, we have a trained model. So what do we do with that? First, we can get what is called a full click probability. So if we have a result list, the ranking, for every result here out of 5, we can calculate the full probability of it being clicked, how likely it is being clicked, no matter what results are around it, just how likely is the second result to be clicked, how likely is it for the fourth result to be clicked. So this is just probability of a click on a certain rank. Full probability. And of course, you can compute also the conditional probability. How likely is the result in the position 4 to be clicked given all the previous clicks? So in this case, how likely this one to be clicked given that the first one was clicked, second wasn't, and third wasn't. So this is a conditional click probability. Now, how do we use these quantities? Let's see what click model can give us and how we can use that output. The simplest output, well, not the simplest, sorry. We started with full click probabilities. So going back, this one here. So full click probabilities are used for model-based metrics. Actually, you have seen that, you saw that, sorry, in the lecture by Evangelos, where he derived metrics based on user models. So you remember RBP, reward-based, rank-based precision, and ERR, expected reciprocal rank. Those are the model-based metrics because they are based on user models, and we will revisit ERR in a second. So basically, full click probabilities from click models can inform the creation of offline metrics, and they have already done that, and they continue doing that. Now, conditional click probabilities, the second probability that I showed you on the previous slide, can be used to simulate users or to simulate clicks. Basically, you go to the first position, you get the conditional click probability. Well, for the first position, it's not conditional, it's just probability of a click. At position 1, you get it from the model, you toss a coin with that probability, and if the coin shows head, you say, I simulate click. Then you go to the position 2, from the click model, you get the probability of clicking on 2 given the click on 1, you toss a coin, again, it says head, you say, okay, I simulate another click. You go to position 3, get the conditional probability of clicking on 3 given the click on 1 and click on 2, and toss a coin, get 0 for tail, and so on. So this type of thing you should use in your assignment to simulate clicks, and we use it a lot in our research to simulate clicks. Finally, what do click models give us? They also give us parameter values, those gammas and alphas. And I already said that alphas are supposed to be unbiased indicators of relevance. And of course, you can use those in ranking. You can use those as features in learning to rank. You can use those in online and counterfactual learning to rank. So these are the most widespread applications of click models. And I would like to focus on the first one, on model-based metrics, and just to revisit what you already saw together with Evangelos, just to connect click models to evaluation, actually to offline evaluation. And there are two, let's say, general types of metrics. Utility-based metrics. It's how much utility, the expected utility you get after examining n results. So you go over n. This is the expectation of utility. This is the utility of each document. Let's say each document has its own utility, and the expectation of the utility is, of course, the utility multiplied by the probability when we get this utility. And we only get the utility of a document if we click on it. We click and go and read, and then we obtain some utility. So the expected utility is probability of click, full probability of click, multiplied by the utility. And this can be, for example, relevance. And the relevance can be binary or graded. That doesn't matter. So this is utility-based metric. Another metric is the effort-based metric. So here F is the effort, how much effort it takes us to actually examine perceived document at any position. How much effort this one takes, how much effort this one takes, this one. And this is the expected effort. And how do we calculate the expectation of the effort? Now, click doesn't really help here, because if we click and that document is not relevant, then the effort is in vain, let's say, right? The effort only should be only considered when we get a success. So this is the probability of success. So basically we clicked on 4 and finally we were successful, and then we add to the expected effort. So the expected effort is the effort by the probability of success. And now this probability, let's try to look at this second type of metric, effort-based metric. And yeah, I forgot to mention here that these two come from click models. Now, this you saw, this is a full click probability. This we haven't seen yet because PBM and cascade models, they don't have the notions of success really, or satisfaction. So in the book, we call it satisfaction. So a user is satisfied. Yeah, let's actually stick with satisfaction better. But some click models, and actually more advanced click models, they have this notion of satisfaction. And let's see how it works. Now, let's get back to ERR that you saw a few weeks ago. Now, reciprocal rank is just 1 over the rank of the first click document, or we say the first document where we were satisfied. So it's a 1 over rank of a document where satisfaction is 1. So the expected reciprocal rank is obviously 1 over R multiplied by the probability of satisfaction. That's just by definition of expectation. Now let's try to devise this from some click model. And that click model that we will use is called dynamic Bayesian network model, DBN. It's a type of a cascade model. So the next click depends on the previous click, but it allows multiple clicks. So the first rule is the same as cascade model. Attractiveness is alpha. Second rule is again the same. First result is examined with probability 1. Now the differences come. If we are satisfied with the document at position, let's say 1, we do not go to position 2. So we do not examine position 2 if we are satisfied with position 1. If we are not satisfied with position 1, we go to position 2 with certain probability gamma. So we can still stop position 1 even if we are not satisfied. And this is determined by gamma. Now, if we don't click on position, let's say 1, we don't click, then we cannot be satisfied. Satisfaction equals 1, the probability of that is 0. We can never be satisfied without clicking. If we do click, we can be satisfied by a certain probability. We call it satisfaction probability. So basically, now instead of just one set of parameters alpha, we have 2 sets of parameters. This is called the perceived relevance, the relevance that we perceive from the snippet. And this is the kind of actual relevance, the relevance from clicking and reading the real document. So there are 2 huge sets of parameters, alphas and sigmas. And let's try to see what is the full probability of satisfaction from this DBN model. Now we can decompose satisfaction into this. Satisfaction is, so you know, when we don't click, again, if we don't click, we are not satisfied. So basically satisfaction equals 1 is satisfaction given a click by the probability of click plus satisfaction given no click by the probability of no click. But satisfaction given no click is 0, so that cancels. Basically, satisfaction is the probability of click, satisfaction given click. Now, this we know from here, this is sigma. And this we have to decompose further. So sigma by probability of click, again, we decompose the same way, but based on examination. Oh, I'm too fast here, sorry. But basically, the probability of a click can be decomposed in the same way. If we go back here, you remember that click happens if and only if we examine document and the document is attractive, right? So that exactly this attractiveness. So the document should be attractive for the click to happen and should be examined for the click to happen. So this decomposes into attractiveness and examination. But examination is cascade. What does it mean that the document in position 3 is examined? It means that all previous documents were not satisfying and we moved further. So they were not basically, they were not satisfying. That this is what it means. We were not satisfied. 1 minus complete satisfaction, no click and no satisfaction. So basically, to move further, we have to be dissatisfied, and for that we either don't click or we are not satisfied, and this is the full probability of not being satisfied. But if we are not satisfied, we still have to toss a coin with probability gamma to move further. So if we to go further, we have to be not satisfied, and for that we need no click, and we need examination of the next document to be gamma. So the cascade happens like this: from 1 to r minus 1, we need to move forward every time and not being satisfied every time. You can derive it on the paper if you like, but this is the idea. Now see, we have this quantity sigma by alpha everywhere. What if we replace it with something called r? So now this is how the probability of satisfaction looks like, and maybe it starts looking familiar already to you. And now if we put it into ERR, this is what it looks like. And now this is exactly the ERR formula that you saw in the lecture. Maybe you saw the version with gamma being equal to 1. That's possible because that's the usual setting for gamma. You say gamma equals to 1, and then this is your ERR. That's how you derive offline metric from a user model. I hope that was interesting for you. So, in summary, what we've seen in this set of videos, we talked about interaction a little bit, and we said that interactions are very diverse, and they're biased, and they are applied to evaluate and improve IR, and the next 2 lectures will be specifically about that. But then we talked about biases and the need of models. We discussed the position-based model, the cascade model, and we also discussed applications, and we focused on offline metrics that can be created based on click models, and we discussed ERR again. So we revisited ERR after Evangelos. And the main point of reference is the book. And again, in the next lectures, you'll see how learning to rank and evaluation can be connected to interactions.